Good morning, good afternoon, good evening, wherever you're watching from around the world. Welcome to today's webinar. I'd like to bring in friend to the program, Charlie. Hey, Charlie, welcome back to the Tanzu webinar program. How are you doing?
Great. Thanks for having me here. Hopefully my internet's good for today.
It looks good. Looks good so far. But before we get started, before we hand this off to you, I do want to just cover some housekeeping items. We love to keep this as interactive as possible. So if you have any questions for us, please submit them using the Ask a Question tab below, and we'll get to your questions throughout today's presentation. In addition, we know that you guys are here to hear from us, but we'd love to hear from you. So if you have any feedback, also let us know hitting the Rate This tab below the presentation screen. Let us know how we did, how we're doing, and what you'd like to hear at future events. Now, I know you're not here to hear from me, so we'll throw this back to Charlie. So Charlie, off to you.
All right. Thanks, AJ. All right. So let's talk about surges to savings, right? And how VMware can help you out. I've been dealing with GemFire for quite a while and helping customers out with getting the most out of GemFire and making sure that applications can stay up running underneath the most demanding situations. So hopefully some of my experience can jump out and hit you from this webinar. All right, so what are we going to talk about it? First, what is it and why do I even say the savings part, right? So we're going to hit on that in the beginning. Touch on a little bit of traditional web application architectures, because that's normally what gets us into these issues. And then a little bit about what VMware GemFire is and how to dive into the details. All right, so hopefully everything will be right on target for helping you out with whatever is going on. So not too long ago, Taylor Swift had a concert, right? And these tremendous demands from fans to go get tickets brought the system down, right? So how, just do some reflection on, what you've seen in your areas, right? And this is not just a isolated incident with Ticketmaster. There's many places where this has happened. So if we kind of like look around on the news, I think it was Groupon and Oprah Winfrey mentioned something about this coupon being there, brought down Groupon, right? First day of healthcare.gov crashes at 7 a.m. the first day, right? I forget what was the number of users, concurrent users that they had, but they didn't even plan for that. University of Cambridge, when they published Stephen Hawking's thesis, you would have think by 2017 we would have figured this out, right? That you need to have some kind of application caching in your architecture. But as we'll see, COVID hit in 2020, and Coinbase, right? So everybody wants to get in on crypto. Crypto was doing good at this time. Super Bowl ad crashed crypto, Coinbase.com. And then Ticketmaster just recently, right? So it's over and over again that we see these patterns of traditional web architectures just not being able to handle what's going on, right? Or they could, but you need a really advanced data engineering team to help you out with making sure that it can stay up. Simplification with something like GemFire would help out, and it's because it's built to scale, not made to scale. And this is kind of funny. Just yesterday, I was logging into like a community website that I belong to, and they asked us all to log in and hit the place, and sure enough, there's the maintenance. I didn't want to dig into where what are they using on the background, because I'm part of the community. I could go help out on it, but yeah, it happens everywhere, right? And this would be a smaller community, still happens. Large communities, we saw it there too. So why does this continue to happen, right? Just the unplanned, unestimated demands, right? So sometimes you just need to scale out, right? Sometimes scaling a data system isn't as easy as, say, the app tier, where I can just throw another Tomcat instance, or say, CF scale, or increase your stateful set in Kubernetes, right? So sometimes it's not as easy on the data backend. So hopefully you start thinking about choosing a data backend that can scale. And then even thinking about scaling complexities. Sometimes when you scale with some of these other technologies, you almost have to reshard your data, right? So your application has to be recoded and redeployed. So hopefully you kind of start thinking about, well, is there a product that, like GemFire, that could help out with scaling complexity? Separate the concerns of that scale, and bring it, make the application as simple as possible. And behind the scenes, the database is working for you. And then time, right? Everybody needs more time to think about how to architect your, time to market, thinking about that. And like I said before, you might have to reflect. And if this was interactive a little bit more, we could have said, hey, did this happen to you in the past? And what lessons learned did you get out of there, right? Was it just a back end of Postgres and we needed to scale up? Was there disaster recovery happening, or some kind of HA plan that wasn't brought into the concern? All right, so let's get into what does a traditional architecture look like? Most of the time, everything's pretty good, right? Like if you think about this stack that I'm talking about here, it has quite a few different buzzwords in there. But you just think about your front end. It could be a web device, like Chrome or Firefox. It could be your iPhone. Maybe it's an application on there. Maybe it's a old desktop app. We still work with those, right? And the back end could just be about anything, right? Spring, J2EE, some other system, whatever it is, you have some kind of backend, and then you have your database. And this is where most traditional architectures kind of fall down, right? They don't think about the scale, right? So if I just have a single Postgres or MySQL or Microsoft SQL, maybe, they have plans to scale out, but they're not as easy as, say, something that's built to scale from the ground up, right? So traditionally you'd start off with just having one, and then you go live, and then you might have an outage. So let's talk about what happened, right? Why do these traditional databases fail, right? They were built in a different, if you think back to whenever the first version of SQL came out, they just had a different concepts, right? 32-bit machines were still pretty prevalent. Disk architectures, right? Is very heavy on there. And the disks were kind of slow, right? So a lot of concepts that might be limiting them with scalability leads to their inability to scale out properly. Right. So if you think about under load, concurrency issues, right? Or what kind of locking are we doing on the database? How is the locking implemented? And then when we think about when we are storming in this thing, we come to saturation. You got to think about, what was your disaster recovery plan, right? Do you have enough data centers to fail over to, right? Are you active, passive, right? And, how do I ensure that, hey, when that machine ultimately failed because it heated up so much, how do we make sure that we're still operational when it does come down to those, storming of influx of data requests? And then likewise, you might have a geospatial geo incident, right? So on the West Coast, there might be a hurricane. I mean, on the East Coast, there might be a hurricane. Well, we had one, a hurricane on the West Coast as well. But anyway, you have a weather event, and it takes down a data center. Can you handle it being, 24/7 operations with your current data architecture? Anyway, GemFire can help out with almost just about everything here. Well, just about everything. So let's jump into what is GemFire, how can it save you? I'll get into some programming details, but I'll try to make sure that they're high enough for a webinar, so that way we don't get into the super big weeds. But I wanted to at least empower the team that's listening to this to just walk away with as much knowledge as you can to understand where GemFire perspective is. All right. I think I might hit the forward button twice. Nope. All right. So VMware GemFire is an enterprise-grade, high-speed, in-memory compute data grid, high performance. Anyway, all that really says to us is that GemFire was designed to respond in sub-millisecond use cases, right? So, and then it has an ability to scale across data centers, across the globe. It was built with the idea of scale in mind, keeping your data safe no matter what's going on. All right. Because it was built in, say, the current generation, right, we're able to do locks in memory versus on disk. So we're going to be using a lot of RAM or in-process techniques to achieve this high performance, right? One thing that was also a key tenet to us is being able to grow or shrink dynamically with no interruptions from an application perspective or data loss, right? So a lot of customers, when they want to bring scaled down GemFire, they just pull the plug on their VMs, right? So GemFires automatically will detect the failure and heal. The applications had no idea what's going on. And then when they need to scale up because they're coming around to, if you think retail Christmas season, they'll be able to scale up just by throwing another node in there and having GemFire automatically bring that node into the cluster, and then the applications can start using that as additional throughput, additional storage, whatever the scale is that's needed. And again, remember, that's no interruption to service or data loss. So you can actually do it live.
Hey, Charlie, it looks like your sound is going. We couldn't hear you for like the last minute. It was a lot of static coming through. Are you able to change the mic setting on there, Charlie?
I'll assume it's better.
There you go. Now it's better. It's good.
All right. Okay, so I'll go back one slide and kind of like recap it a little bit. So GemFire is able to grow and expand dynamically. So I'll assume that we got the first half of that, but you could just throw another node on there and scale up. And likewise, some of our customers, when they want to scale down, they just kind of kill a node. So really good stuff. All right. Another feature of GemFire is its ability to handle multiple geolocations, right? So you want to keep 2 data centers in sync. GemFire has an ability to keep those data centers in sync. When we're working with a single data center, we like to think of that as consistent, right? So everything inside a single data center or a single region will be consistent. When we start talking about getting internet, right, going across larger geospatial areas where the performance might take a hit if we had to wait synchronously for a replication, we start doing things asynchronous. And our geo-distributed data replication is asynchronous. So that way we can handle the scale and we can push more data through a given request on the network. So where can GemFire run? So we test GemFire and our customers use GemFire just about anywhere. we can run on, VMware Tanzu, vSphere, Taz, Kubernetes, including OpenShift, right? So we test with that all the time. And where else can we run? Well, public clouds, private clouds, hybrid models, right? Some customers are using that geospatial, our WANs, our ability to do the geospatial replication. We have some customers running private cloud and hybrid up in the public cloud in a hybrid model, just using that. And then for the advanced, where every iota of horsepower is needed, we have plenty of customers running on bare metal as well. So where can we run? Wherever you need us to. All right, customer use cases. Where is GemFire being used today? We're used in just about anywhere that I can think of, right? Here's a couple that I said, all right, I made a word diagram of places that we're running, and here's some top ones that came out, right? So we're definitely in the travel industry. My background is in the government, and we have a pretty big deployment in the government area. I did telco for a while, so getting the network to actually respond and react to what's going on there. I did some development work with GemFire to make sure that it can do some analytics on the network to ensure you have a better call quality. Financial industry, GemFire is used in trading applications, banking, everywhere, just about everywhere that I can think of in the Wall Street area. Manufacturing, definitely in there. Media, all the rest of them, you get the idea. We're just about everywhere. So if you end up coming in, we can have a chat and help you out with whatever your concern is at your company. All right. So what happened? Let's revisit that the traditional architecture, right? And there's many ways to think about GemFire. It can be a system of record, or it can just help you out with caching use cases. So if I was just to quickly say, how do we get those applications that were buckling underneath that stress of that storm surge? Throw a GemFire in the middle, and it can protect that backend system, right? So GemFire itself has a higher load tolerance, right? Because we're responding at sub-millisecond performance, right? So we don't need much CPU. Higher concurrency, right? So as we can scale up, we, near linear scalability, right? So I add another node, there's going to be some scale factor by adding that extra node in there. So I can get a extremely high concurrency rate. And then likewise, we can scale at one rate where the applications layer is scaling at another direction. So it's like I say, the GemFire's being the umbrella for your backend system, because we're offloading all those requests, right? There's going to be I'll talk about some of the patterns in a second here, but I was going to go into that chat, but I remember I had another slide where I talked about it. So let's talk about, what does GemFire look like when you deploy it? Well, there's two components inside of GemFire when you deploy it. We have this concept of a locator, which is like our version of service discovery. It does a little bit more than just a generic service discovery. It gives like load conditioning information, and also when you're hooking up monitoring, you would normally attach it to a locator. It also helps out with any load balancing, and when you follow our instructions, it ends up being also the coordinator for the grid, right? So that's an advanced topic. I don't know why I went there, but there's a lot of good stuff that comes out of the locator. The things that are doing the real work is the cache servers. This is where it's providing the storage and running the queries and doing all the really good stuff for you and keeping your data safe. That's the cache servers. I threw them up here in like this 3x5 deployment, just to talk a little bit about we are a distributed system, and I'm always thinking about high availability use cases, right? So sometimes, some people ask me, hey, could I just deploy one instance of GemFire? Yes, you can. 100% you can. We work fine that way. However, then you don't have like high availability, right? So if one cache server went down, well, I only had one in my architecture, so now my application's offline if that one instance ever went down. So 2 would get us to high availability, right? One instance is there, it crashes, the other one's there to pick it up. There's a concept of 3 that I like to have, right? So if, let's just say I was doing a rolling upgrade and then there was a hardware fault, well, at least I can be still up and running if there's 3. If there was 2, I might actually take an outage on my site. So I like to keep things at the minimum 3 and then just scale out for whatever you needed for storage or CPU. It depends on whatever your application's heavy on, right? From an architecture perspective. Okay, I think I beat that one down to death there. All right, let's talk about a little bit of a concept inside of GemFire. We store our data in something we call a region. It has a strong analog to the SQL world, like a table, except for GemFire is just a key value store, right? So it stores its values in just, keys and values. And then the values themselves are objects. And the objects can be as deep as you want or have arrays or whatever it is. And it's really flexible to just be thinking about keys and values. To take advantage of that ability to store objects or descend into objects or have collections inside your objects, we use for our query language something called OQL. Looks pretty close to, I'll have a sample in a bit, looks really close to SQL, but I can actually iterate through collections inside of objects, and I can descend their hierarchy so it's not as flat as SQL is. But it feels, for the learning curve for SQL experts is pretty low. All right, so how does it actually work? I mentioned that it's a key value store. So in programming languages, for me to do any storage operations, it is just a put. So I put my key and my value, and likewise, when I do a get, I can do a get on my key, and out comes my value. Really, really basic stuff. I mean, and think about all the stuff I've been talking about with scaling out, right? So scaling out to GemFire, getting that how to scale, all that good stuff just comes from those 2 simple APIs. And then how does it work? Let's go on to the next one. So here's the example of the query that I was using. This one I'm just selecting my positions and the positions that have Pivotal in there. I thought I switched this over to VMware at some point, but looks like I missed this one. But anyway, so now I can go through my example regions of the values P, and I'm looking for where I have a position of Pivotal in it. So that gets you there. What else do we work with? So GemFire team works alongside of our Spring team, right? So Spring, Data, GemFire. We're the makers of Spring. We have team members that influence what's going on in Spring. Same thing with the Spring team influences GemFire. So best in class ecosystem for your Spring Data, Spring Boot, Spring Session, all can be used with GemFire. So that's some good stuff. And let's go on. So here's our common data storage patterns that I was alluding to in a previous slide. So where can I use GemFire? System of record, that's the one I like the most. Makes everything really simple. I don't have a complicated architecture. It's just storing my data. I've done many systems or helped out customers with many systems that are using GemFire as a system of record. However, I also know that GemFire sometimes is just helping you out with making sure that you can stay up during surges, right? Or your backend system is starting to lag because you're putting more demands on it. So how do I offload some of that work? All right, so that's where these other patterns come into effect. So the cache aside, this is the first putt. Like a lot of times customers are saying, how do I get on board with GemFire? The cache aside pattern, what this is the applications in charge of caching. Good enough, right? You just say, hey, go get my value out of GemFire. Oh, it's not there. I'll go load it from my backend system and do a put, so that way I can go get it next time. Really easy stuff, and I'll show an example of it in a moment. Oops. But the other one that I like better, I wanted to go back a slide because I accidentally hit forward, is the read and write through pattern. This one I like a little bit more because GemFire is acting as a coordinator, right? So let's think about I'm loading up a web page and it's a profile, like I logged into my banking, my bank account. And inside there, I have about 12 different panels on my screen, and it's all asking for Charlie's profile and how to render. Well, with the cache aside, you'd get some number of cache misses before you got the hit and loaded data in there. So you could have more back-end hits with cache aside. If you have GemFire control, when I do that get and I have a cache miss, there's like a lock that prevents anybody else from asking for Charlie's information. So they call that the thundering herd or something stampede. Forgetting it right now, but anyway, having GemFire control can prevent extraneous backend requests. This becomes, and it also, you're going to see in a little later, I like it because it also separates concerns. I no longer have to have how to load or interact with that backend system. I've separated it out so that way GemFire is in control of contacting and loading that data. Right behind, that's another concept where, all right, GemFire could be working at one rate, and then say I have a data warehouse that I'm trying to keep in sync with what's going on in GemFire. I could have a right behind where I'm asynchronously writing out a bunch of information from GemFire. So a lot of good stuff there. Right behind is a great one for, say, batch writing to a message queue or batch writing to a somewhere. Really good things. And then the last one is, I don't want to do any of that synchronous or cache hits, cache misses. I just want to have GemFire have all the data and have all the data preloaded. Yeah, that's a use case. We have plenty of customers that are using GemFire as loaded up once a day, once a night, whatever that is. So still out there is a good pattern. All right. So I talked about that we're going to dive into some details. So let's jump into it and see how to do some of these things, right? So we talked about that cache aside, and I'm going to use a couple different patterns here. So I'm doing cache aside. Let's see what it looks like. All that I'm doing is saying, hey, look aside cache, go get my key, and I'm building up my key by my request parameters. If I don't have it, I'm going to go off and call a service on this one. I'm using a REST service. And if you think about savings, maybe the savings would kick in here where that REST call costs $1 per call, right? So now I'm preventing some of those, some of that interaction with that backend REST service. So I store the result and I just do a put. If I have something that came back from that call, I just store the result so that way I can look it up next time. That's all it is to cache aside, right? So that's why I said it's a great entry pattern to get into. Let's go ahead and look at the Spring version of this. So Spring has a concept of Spring caching, and how you enable that, or what does it look like? Well, you could just say that this method, right? I don't know if my pointer shows up here, but I'm looking at the @cacheable look-aside caching. With that one on the search method, it's just an annotation on there, right? Where I can say, hey, if it's a cache miss, so that like think of that if statement where I had the get. If I have a miss, go ahead and call this method, and then I'll store the results to be cached later. And what it does is, how to make that key with the plain Java version. They make up the same key, behind the scenes and stored in an object that they make themselves, right? So a little bit easier to see. You change 3 lines of code for 2 or 3 annotations, right? So Spring is a good place to start too. It'll help you out with some of the boilerplate code. But some people don't like they like to see all that stuff. So whatever way you want to go, I'm good with it. So let's go through and talk about that read through. So with the read through, the trigger is called on a cache miss, right? So we have this concept called a cache loader. So the cache loader gets called on a cache miss, right? So if I'm doing a get and I have a miss, this is where the cache loader gets called. A local cache loader will be invoked. Otherwise, it'll use a remote one. So this is just saying, hey, we'll make it easy on you. You don't have to think about deployments. The cache loader invocation for the same key. So this is me talking about Charlie, right? I'm looking up Charlie's data. The cache loader is going to wait for the first request to respond before it hits another one. So that's solving that stampede of requests for somebody's data. So really good stuff to go with the read through. So what does that look like in a physical deployment? So I deploy some code to the GemFire server. So that way, when I'm trying to do that lookup on a region, it's going to go to the server that needs to be there, call its cache loader, and synchronously load that data. So that GET response has the data that was missing previously and loaded from some backend system, be it a database or a REST service. So what does the interface look like? It has one method called load, and it uses this loader helper. And inside the loader helper, let's see if I put a slide on there so that way I can just talk about it. Nope. The loader helper has a method in there where it can just go get the key. And that's the important part, because you're going to use that key as your contract to call the whatever code that you needed to call that backend service. And again, this is all synchronous. So what does that look like in code? So here I can see that I'm still in my application space. I go build my key and then go to my region and get that key. So now that result comes back. My application has no clue if that was cached or needed to be calling a backend system. So my application concerns went down because I was also, all it needs to know about is that cache. So I removed whatever needed to be called and put that into the place where data requests are being handled. So I really like this pattern. So when I'm on the cache loader, that part that's deployed to the GemFire server, this is all what it turns into. So I go off and do a load, and there's my loader helper. All I'm going to do is go get the key and then call my service and then return that value, and GemFire will store it appropriately in the right region. Super awesome stuff. I love the fact that we can, separation of concerns and optimizing the cost for the backend service. Now, one thing I think, cache writer, missed it. All right, so with the cache writer, there's also another interface, and you would just go off and implement it if you wanted to write back to the backend storage. I think I didn't put in there just because I was on this idea of the bike, the application that I was kind of webinarizing didn't have a write-through pattern on it. Anyway, sorry about that. You can always look for how to do that in our documentation, right? But let's talk about what did we learn today. So we heard about some use cases that made the news, and one that didn't make the news, but it couldn't handle the scale, right? We learned about how GemFire can help you not be in the news, right? That'd be the worst case if your company was in the news just because you had a little bit of data outage and you knew about GemFire, it could help you out with it. We learned about GemFire and how it works, and looked at some code examples to get us into there and hope you start yourself on that journey down the road. Like I said, if you want to learn more, head over to gemfire.dev. You can look at the documentation, download GemFire examples, blogs, and videos. All right, let's see if I have any questions. Let's see, there was an announcement. No, and I'm going to look over here. No questions. I can't think of anything else to share with you all. I appreciate you listening. And if you have any comments or questions, please leave them in the survey. And I hope you have a great rest of the day. See if AJ pops in. There he is. You can help wrap it up for me. Oh, I can't hear you, AJ.
There you go. Can you hear me now?
No, maybe it's me. Oh, I heard you.
Okay, great. Again, just like Charlie mentioned, thank you guys for joining us today. We don't have any questions live here, but if you do send any questions, we'll send them directly to Charlie and we can send a response. And I think we've had Charlie on here before, and I think we'll probably have Charlie on again. We'll make sure we get things set up with Charlie again for a future webinar. We do appreciate the time you guys have spent here today. And if you didn't know, this is being recorded and will be shared on demand shortly after the end of this presentation. So feel free to watch this again or share this with any one of your colleagues, your social networks. We appreciate all the support on this topic. So again, thank you, Charlie. We hope everyone has a great week. Talk to you guys soon.
Yeah, and if you have any ideas for a future webinar, please leave them in the comments. I'd love to hit what you want to hear about.
Absolutely. Yeah, send them in. Leave us a feedback as to what you want to hear in the future.
Yep.
Excellent. Okay, bye all.